Hello everyone. I hope you all are doing good. It's been a long time since I've made any lesson videos. So here I am with the subject analysis and design of algorithms. And the topic that I will be discussing today is called as Horspool's algorithm. In the subject called data structures, you might have learned something called as string pattern matching. And in that, you might have gone through the algorithms like KMP algorithm or brute force string pattern matching algorithm, second string pattern matching algorithm, and so on. Here, we will be learning one more algorithm related to string pattern matching called as Horspool algorithm. What is the purpose of this algorithm? Suppose there is a text and there is a pattern. You want to check whether that pattern is present in the text or not. That is the purpose of this algorithm. Now, you might wonder if we have already learned those many algorithms previously, what is the purpose of learning this algorithm? The main thing that you have to remember is this you can remember for the placements also, and even for your general knowledge, you can remember it like this. See, in all the other algorithms that you have seen so far that is used for string pattern matching, the pattern matching used to happen from left to right. Okay, suppose I had a text called as computer and I want to check whether this particular pattern is present or not. Put. So what I will do, I will put the pattern over here from the left to side and I will go on checking the characters. Now in case of the Horspool algorithm, the check will happen from right to left instead of left to right. That is, I will start the check from the right side. Okay. I will start the check from the right side. See the explanation I have given. The Horspool algorithm is an efficient string pattern matching algorithm that is used to find the pattern, also known as substring, within a larger text. It is an improvement over naive string pattern matching algorithm, and it is a simplified version of something called as Boyer-Moore algorithm. Okay. Now, what is the idea? See, you have to remember this both for the exam as well as for your placements. That is, instead of comparing the characters from left to right, so instead of comparing the characters from left to right, Horspool compares from right to left. Okay, right to left, starting from the end of the pattern and aligns it with the text. And one more thing is you have to remember Horspool algorithm is mainly applied for text which is very lengthy or very long. So if you have a long text and you want to find a pattern pattern, then instead of using other algorithms, you can make use of Horspool algorithm in order to find the pattern whether it is present in the text or not. And one more thing is, okay, like if you remember KMP algorithm, we used to do a sort of pre-processing on our pattern. Here also we are going to do that. See the second line. It says it uses a pre-processing step to determine how far the pattern should be shifted when a mismatch occurs. See, when the mismatch is occurring, you can't just shift your pattern, as you desire the number of digits. Okay. So what we do is in case of pre-processing, we get the idea about how to move the pattern and how many positions to move your pattern in order to get the text. Okay. So that is the algorithm. So you remember like this in case of, see, remember the steps like this or how to write about the Horspool algorithm if it is asked, right? Horspool algorithm is a string pattern matching algorithm. What is string pattern matching algorithm? An algorithm that is used to find whether a pattern or a substring is present in the text or not. Unlike other algorithms that we have seen like KMP or naive string pattern matching algorithm where the shift used to happen from left to right, in this case the shift is happening from right to left. That is the main difference. And Horspool algorithm mainly applies on text which is very lengthy. These points you have to remember and after that you can continue. And as I always say, before I start the topic, you have to know the real life applications of this, right? See, you're just reading a lot of things, you don't know where it is actually applied. See the real life applications of Horspool algorithm. I have made a list of few of them. So you can understand. I told you, remember, it is applied for long text. Okay. So it is used in text editors. Suppose you have a Word document and you have written some contents into that Word document and you want to find a particular pattern in it. So you can make use of this algorithm. Also, in case of bioinformatics, where there is a DNA sequence and you want to find a particular sequence out of that, then you can also make use of this string pattern matching. Likewise, you can also use web search when you want to, suppose you are using Google and you are entering a particular text like food recipe. So everything related to food recipe will come, right? It is also based on string pattern matching. Wherever the website is there, which has used that keyword, so it will retrieve all those websites and give you back. Not only that, it is also used in spam filters. You might have seen that there are some emails which are coming from spammers. What you can do is you can identify some keywords from that mails and you can give it. And if you receive any mail from that particular sender which is having that keyword, then everything will go into a spam folder. So you can relate it like that. Also, in case of e-commerce search. Okay, I want to buy a new shoe. So if I write shoe, everything related to shoe will come, right? So this is the application of Horspool algorithm. I hope you are now getting the idea how Horspool algorithm can be used in real life also. See the real life application. So anything that you are studying here will not go waste. This can be applied in your real life also. That is the point I'm making here. Okay, so Horspool algorithm is a string pattern matching algorithm where the comparison happens from right to left and usually on long text. It can be applied on short text also, but more convenient because of the pre-processing, the shifting takes place, considerably more number of steps so that you can find your pattern much faster as compared to all the other algorithms. Okay. And before I go to that, you have to understand something called as cases. See, in case of Horspool algorithm, there are 4 cases. See, you want to do the pre-processing, right? So in order to do the pre-processing, you need to know the 4 cases. So I will discuss these 4 cases. If they ask you a question in the exam also, you are supposed to write about this. Okay. Now, case 1. Suppose I have my text which is having all these characters. Let's say these are the characters S0 to Sn minus 1. And I have one pattern called as barber. Okay. So I have placed barber here under that from where I want to do the search, for example. Now what it will do is it will compare S and R here. See here, it will compare S and R. S and R are not a match, but it will try to find another occurrence of S in the pattern. So, S is not a match. See, S is not a match to R, but it will try to find out whether S is present anywhere else in the pattern. So, if it is not present, what it will do is it will directly shift the entire pattern to the right of the compared character. So S was the character compared. So everything will go to the right of that particular character. I hope you have understood. This is case 1. When there is no match at all. Let's do case 2. In case of case 2, suppose I have a text which looks like this. And I have a text and a pattern like this. Okay. Now, let's say we compare. So first we will compare B and R. B and R will be compared. B and R is not a match. So what it will do is it will compare whether there is another occurrence of B in the pattern. See, there is one more occurrence of B in the pattern. See, though B and R is not a match, it will check whether B is present anywhere else in the pattern. So 2 times it is appearing. Once it is appearing here, the other time it is appearing here. So what it will do is it will take the rightmost occurrence. It will take the rightmost occurrence. So 1 minute. Okay. What just happened? It will take the rightmost occurrence and it will check from where you have compared how many number of characters. See, this is your character, no? So your character B is here. So it will check how many digits are before it. See, two are there, no? E and R. So what it will do is it will bring the character two places towards the right. Okay, so it will be like this. If you want, let me show you another example. Okay, suppose I am comparing this particular text and let's say like this. Okay, so first I will compare T and E. T and E is not a match. So what will happen is it will check whether another occurrence, is there any occurrence of T in the remaining characters. So yes, there is a occurrence of T, right? And it is two places. See, here there are two characters, no? So it will shift the entire thing two places towards the right, like this. Okay, I hope you have understood case 2. Now case 3. Case 3. So suppose I have S0 and I have something like MER, then S. What exactly is happening here? I don't know. Yeah, like this. Why is that heart symbol? But try to cover it at least. No. Okay. And I have leader. Suppose I'm searching for the pattern leader. See, R and R is a match, E and E is a match, and it will check now M and D. M and D is not a match. So, how does the next step work? It will check whether M is present in the remaining characters. M is not present, right? Now, what do you think should happen? See, R and R is a match, E and E is a match, M and D is not a match. So it will check for another occurrence of M anywhere else in that particular pattern. So it is not there. So what do you think should happen? If there is no occurrence, directly everything will shift to the right. Like this. Okay. So this is how the case 3 works. Let's go to the case 4. Case 4. Okay, now I have something like this. Yes, I have some characters like this. Then Sn minus 1. And I want to search this particular pattern. Okay, now you see R and R is a match. Correct? R and R is a match. It will check whether A and E is a match. So it is not a match. Okay, it is not a match. So what do you think should happen now? It's slightly a little bit trickier compared to other cases. See, R and R is a match, A and E is not a match. But if you see here, R is present somewhere else also, right? R is present here also. So what it will do is, one second. What it will do is, it will shift the characters, okay? So your R will come to this position here. So O, R, D, E, R, like this. I hope you're understanding. This is very important because if you want to shift, you need to know this. Okay. So there are four cases, sorry. So in one case, you're checking if the character is not matching, it will check for the occurrence. If the occurrence is not there, it will shift the entire pattern towards the right. In the second case, what it will do is if one character doesn't match, it will check whether that character is present anywhere else in the pattern and move accordingly. Okay. And in the third case, if some characters are matching and if there is a mismatch at a particular position, that character will be checked with other characters in the pattern. If it is a match, okay. Otherwise, it will shift the entire pattern towards the right. And the other thing is, in case of this one, what is the case 4? It will, if the character is, if one character matches, so you go and check for the next character. When the next character is not matching, if the previous character is already present, you can shift with respect to that. Okay, so that is the 4 cases. I'll show you some examples um, of Horspool's algorithm. Okay, this I have taken from the past paper only. So pay attention and learn this one. Okay. So you want to find whether there is a pattern called as barber in the particular text. So Jim saw me in a barber shop is your text and pattern is barber. Now you want to check whether that particular pattern is present or not. So what you do is in the step number 1, we do pre-processing. Construct the pre-processing table. Pre-processing table or get the values, that's all. Okay, just to make it look more organized, I'm writing it like this. So my pattern is BARBER. Okay, now what I will do is I will put the values. Okay, so how this works, see, always for the rightmost character put 0. No matter what it is, rightmost character should be 0. Then next character should be 1. Okay. Then 2, 3, 4. But for this particular B, what you do is check if there is any presence of B previously. For this B, check if there is any presence of B in the previous character. See, B is already present, no? So instead of writing 5, take the value 2. Okay. Let me do one more example just to make it clear. Let me take my own name. So initially 0, then 1. See, now you might get confused. Okay, see, first character was A. Okay. Now when I come to this position, should I write 0? No. 0 is for the initial character, so that should not be considered. So this will become 2. Okay. D will become 3. N will get the value 1 because N was already here and its value is 1. Okay. And what about A over here? A will get the rightmost occurrence. So this one. Rightmost means as in other than the 0. So this will get the value 2 and this will be 3. Sorry, 3 is already done, no? So it will be 4. I'll show you one more example. See, let's say you like I want let's do this one. Shell. Okay. Now S0, L1. Next L will not get 2 because L3 is already present and will take its value. E is not present previously, no? So that will become 2. H will become 3. S will have the value 4 because you should not get confused. S is already present here, but the initial value should not be considered. So this will become 4. I hope it is clear. So what about A, B, C, Ds? In this case, there is only S, H, E, L, S. No. What about other characters? Other characters will get the total number of digits in your pattern. So your pattern is having 6 digits. No. So everything will be 6 like this. Okay. So that is how it works. Let me show again for barber. See, you will write like this. barber. Then you will start putting the value. So initially right side one will get 0. Then E will get 1. B will get 2 because there is no occurrence of B to the right side, right? But R, you shouldn't get confused. Rightmost character will not be considered. So this will become 3. A will be 4, whereas this P will get the previous occurrence. So this will become, remember, and other characters. So if I'm constructing the table, it will be something like this. So A, B, C, D, E, then R is there, then up to Z if I'm taking. So B will be 2, A will be 4, C, no, E is how much? E is 1, E is 1, R is 3. Other everything will get the total number of digits. In Barber, you have 6 digits, no? So this everything will be 6 itself, like this. 6, like this. I hope you have understood. This is step 1. Now, step 2 is pattern matching itself. Pattern matching. Okay. So what you will do is you will construct you need not write the table so elaborately like how I have written, because I just want to, make it look neat. So I've written like this. What is the text we have? Jim saw me in the barber shop, right? So let me write Jim saw me in a barber. Jim saw me in a barber shop. Okay, now let me start the matching. So it is barber. So I will start from here. Okay, now you see what is the process? Check whether the rightmost characters are matching or not. First, you will check A and R. Is A and R a match? No, this is not a match. Now what will happen? It will check whether A is present anywhere in the other part of your pattern. In other characters, whether A is present or not. So as you can see, A is present over here. Correct? A is present over here. Now what it will do is, it will go back to this pre-process table. See, pre-process table. So it says 4, right? It says 4. So what it will do is, it will shift your pattern 4 places towards the right. So 1, 2, 3, 4. Okay. After that, it will place your pattern like this. I'll do it again, just if you're confused to see. Okay. So A and R is match? No. A and R is not a match. It will check for another occurrence of A. A is found over here. Now I'll go to its pre-process table and identify the value 4. So what it will do is, it will shift your entire character 4 places towards the right. So this is 1, 2, 3, 4. So barber would come to this position like this. Okay. Now let's continue the same thing. So what it will do is, E and R will be checked, no match. But E is present over here. So it will go back to the table and identify its pre-processed value. It says 1, right? Now what you're supposed to do? Move your text 1 place towards the right. E-A-R, B-E-R, like this. Now what will happen next? Underscore and R. Okay, underscore and R is not a match. What it will do? It will check for another underscore in your pattern. Is there an underscore in your pattern? No. So what it will do? It will shift the entire pattern to the right. No positions and all. Entire thing will be shifted. So barber would come to this place. I hope you have understood. Okay. Next. So here, these two, okay, will be checked. So, so B and R, not a match. Check for another occurrence of B. Yes, right here. So go and check its pre-processed value 2. So what are you supposed to do? Shift your character 2 places towards the right. So 1, 2. After 2 positions, you shift. So it will come here. Hold on. So B-A-R, B-A-R, like this. Okay. Now, another thing now. See here. R and R is a match. Okay. R and R is a match. Then it will check for A and E. A and E, not a match. Now what it will do? See, here you see R and R is a match. R and R is a match, whereas A and E is not a match. Now, in this case, what will happen is it will check for another occurrence of A. Is there another occurrence of A? Yes, it is. But what happens here is in this particular case, it comes under one of these cases. See, be very careful here. R and R is a match. So it will shift towards the right. A and E is not a match. Now you shouldn't get confused whether I have to check one more occurrence of A or not. See, in this case, this is a match and this is not a match. Correct. So whichever was a match or the rightmost occurrence, with respect to that, you shift. So R's value is what? R's value is 3. So leave 3 places and then you shift your character like this. That is how, see now everything is matching. So this is how you do the string pattern matching. Let me do one more example so that it becomes clear. See, text is boss knew about Bobabs and I have slightly changed. If you see your past paper, there was one more character. I just changed it so that it is not the same. So step 1 is BOBAB. Take your pattern. Right side 0, then 1, here 2, 3. This shouldn't be 4, this should be 2 because B is previously present and its value only that will take. Now let's do this. Okay. So Bobab. So BOBAB. Like this it will. Check now. Do the pattern matching. So rightmost occurrence not a match. Rightmost occurrence is not a match. So underscore and B is not matching. So ideally it will check underscore anywhere else in the text. So anywhere else in the pattern, sorry, underscore is not present. So what you are supposed to do? Shift the entire thing towards the right. Correct? Again, underscore and B not a match. So what are you supposed to do? Check for any other occurrence of underscore in your pattern. No. So entire thing will be shifted. Sorry. Huh? Hold on. One minute. Okay. Like this. Now let's 1 minute. Okay, I'll do it again. So BOBAB. So not a match. So entire thing will be shifted. So here not a match. Again, the entire thing will be shifted. Again, T is not a match, so no other occurrence of T, so the entire thing will be shifted. Sorry, spelling wrong. Okay, now here, this and this. A and B is not a match. Check for another occurrence of A. Yes, it is. So check its pre-processed value. A's pre-processed value is 1. So what are you supposed to do here? Move your character one place towards the right. And you are finding the match. Like this. Okay. Let's do the next example. Pattern is earn. So step number 1. Pattern is, sorry. Sometimes when we are writing, because of the sensitivity of the screen, the things will just go off. Don't mind that. But I hope you're understanding the uh, idea and the lesson that I'm teaching you. So earn, rightmost 0. This is 1, this is 2, and this is 3. Okay, remember. Now place the characters. So E, A, R, N. No match. So check for any other occurrence of L. No. So shift the entire thing like this. So A and N. Here A and N is not a match. A and N is not a match, but A is again present over here, right? So go to the preprocess table. It says A's preprocess value is 2. So shift the entire text 2 places towards the right, like this. Now S and N is not a match. There is no other occurrence of S, so shift the entire thing. Okay, so now R and N will be matched, no match. R's presence will be checked. R is present right over here. So go back to the preprocess table. R's preprocess value is 1. So shift the text to one place towards the right, like this. Again, check for S and N. No match. Check for another occurrence of, check for another occurrence of yes, nothing is there. So shift everything towards the right. Again, here T and N will be checked. T and N, no match. Is there any occurrence of T? No. So shift the entire text towards the right. Again, P and N will be checked. This and this. No match. There's no occurrence of P. So shift the entire thing towards the right. EARN. Okay, next again. See here, N and N is a match. I and R is not a match. I and R is not a match. Now you will check for N. N's value is 0, no? So entire thing will be again shifted towards the right. See here, A and N, no match. A and R, not a, L and E, not a match, but A's presence will be checked. A is present over here. Its value is 2. So shift the entire thing 2 places towards the right, like this. So now there is a match. What it will return, it will tell whether there is a pattern present or not, and it will return the first position from where the match has occurred. Sorry, the match is not occurred over here. The match actually is from here. So position, okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 23, 24, 25, 26, 27, 28, and 29. So 29 will be returned, saying that the pattern is found at the position 29. I hope you have understood. You can take up some more example. I'll give you one example. You try for this one. Okay, I'll give you a simple one. Let's say the text is computer science, computer underscore science. Okay, the handwriting. ah, Usually my handwriting is not like this. But yeah, I don't know. I'll write here. So text is computer science. There's no space, there's an underscore here. And your pattern is UTER underscore. Can you do the string pattern matching using Horspool for this particular example? Try, okay? So I hope you have understood how to do the manual calculation. This is a very important question in module 3, usually asked, so you should know. Let's go to the algorithm. Okay, there are two algorithms. So two steps are there, right? One is to do the pre-processing and the other one is to do the string pattern matching. So one is for your pre-processing. This one will be like the pre-processing. So it will give you the shift size. By how many characters can you shift your character? It will be given by this particular algorithm, the first one. So the input is your pattern, which is having the indexes. The characters are m number of characters. So the indexes go from 0 to m minus 1. Okay. What is the purpose? It fills the shift table used by the Horspool's and Boyer-Moore algorithms. Input is your pattern. Okay. The pattern will be given and output will be the shift size. Okay. Now you see here in this case, what is happening? See, for example, if I have a pattern something like this. Okay, this is your pattern. This is your pattern. Initially, what we assume is, okay, we assume that the text, whatever pattern we have not got the initial value. So if you remember, in case of barber, for this we know the shift values, but what about the other characters? So that C, D, till Z, what we do? Initially, everything will be the total number of digits, right? So here also, see, M means the total number of digits in your pattern. So what initially we'll do is for all the characters, we put the shift size to be M itself. Okay. Then what we do is, again, we recheck. So M minus 2, M minus 1 is the last index. So ideally, last position is not checked. No. So you remember BAR, in that the last position is not checked. This is M minus 1 position. So we go up till M minus 2. And you can put this, you can check, you can take some values and check if this actually works. This will work. This is a, getting your new shift size. Okay. So you will get that table, that will be your return type. Now doing the string pattern matching. See, two things will be there. One is your pattern and the other one is your text. Correct? So what is the purpose of this algorithm? It is to implement the Horspool algorithm for string matching. Input is a pattern and text. Output will be the index of the left end of the first matching substring. And if there is minus 1 means there is no match. So yeah. So you will get the shift table using that previous algorithm. Okay, then what you will do? See here, this particular step. Okay, so your pattern is here. Sorry, let me take the text. First, let me take the text. So let's say this is the text. And your pattern is somewhere over here. Right now, you're doing the comparison. See, I want to get this, I want to place my pattern in the correct position like this. Okay. So this is from 0 to M minus 1, right? So I want to get this position from where I will do the comparison. So M minus 1, see, this is M minus 1, no, last position. So I am assigning to a variable called as I. So I is equal to m minus 1. From here, I will start doing the comparison. Next, I will move the pattern like this, then I'll move the pattern like this. Till when I will do? Till the last index. So I is less than or equal to n minus 1. Till then, I can move the pattern is what I'm trying to say. And I have one variable called as k. It will give you the number of matched characters. Remember, it is for the matched characters. Now, see, if there is a match, okay, then increment the value of k by 1. And at the end, you will, if the k becomes equal to m, that means you have found your entire pattern. See, you will go on increasing k, right? K means the number of match characters. So, till where can the match happen? The match can happen till the total number of characters. So, if k becomes equal to 1, then you will return that position. This I told you, no, the position will come here. So it will be I minus m plus 1. That will be the position. Okay, else it will shift your character based on the table size. So I will shift. See, I is here, right? For example, if I is here, if I is here and you want to shift it based on some shift size. So you're adding the shift size to that particular index and you're shifting it. Else return minus 1. I hope you have understood the concept, a very important concept in the third module of analysis and design of algorithms. Let me recall everything that we have seen. The first thing we saw is what is Horspool. So Horspool, a classic pattern matching algorithm for strings where the comparison happens from right to left. So you're comparing your pattern with the text from the rightmost character and then going towards the left. Okay, some applications also we saw. Do you remember the applications? The applications are for any string pattern matching. For example, in case of Amazon.com, I want to find a shoe. So how are you, when you're typing shoe and pressing enter, how are you getting all the results related to shoe in one glance itself? That is because of this pattern matching. I'll compare with all the items and if the keyword is matching in any of the titles, it will give that result. Correct? So that is what is happening. And then we saw how to do the 4 cases because you want to know how the shift happens, right? So we saw those 4 cases. Then we saw some of the examples also. The example is usually asked, apply Horspool algorithm to find if the pattern is present in the string or, and I have done some examples. And I've also discussed the algorithm. There will be 2 algorithms. So if they tell you to design the Horspool algorithm, you're supposed to write the shift table algorithm as well as the Horspool algorithm. Okay. So yeah, that's all about it. So I hope you have understood all these things that we have discussed. Okay. So yeah, I'll stop the class here. Thank you so much.